We have to test it. I think it will work for entire 1 hour, but let's see. I think it started recording here. Yeah.
Acha.
So today we start with data acquisition, which is a very important part of machine learning. I mean, when we solve any machine learning problem, we create a training pipeline of blocks, which essentially helps divide the. I mean, from data acquisition till learning a machine learning model, there are multiple steps, and we have divided the steps into some specific blocks. The first block is data acquisition. So first block in machine learning pipeline is data acquisition. This step is responsible for acquiring data from different sources and in different formats. So data can be in different formats. In this basic session, when we are now not concerned about image kind of data or let's say textual data. What we are considering right now is a tabular data or a structured data. Now, before this pipeline, there are three types of data. I'll come to this in more detail, but you just remember the first step is we want to acquire data from different sources and in different formats. Different sources, as in what can be the different sources? The different sources can be some database, some data is there. You have a file, Excel file, you can have a JSON file, you can have a CSV file, or maybe the data is in a where URL from where you want to get the data, or maybe it is in embedded. Let's say you have a Flipkart site and from there you want to extract relevant data and create a tabular structure. So there are many sources from which data can be acquired, and that is where this data acquisition block helps. Next is data cleaning block, wherein after acquiring the data, it can have a lot of junk information which may not be very relevant or may not be suitable for learning a machine learning model. So for which purpose we do a little bit of data cleaning. Now once the data is cleaned, we do data pre-processing. So data pre-processing can involve things like normalization, imputation, data transformation, many other things within data pre-processing which can help improve the learnability of your machine learning models. Now once the data is cleaned and processed, the next step is model training. So this is where the you learn a machine learning model, you try different combinations of machine learning models as well here to see which one is doing better. Now once you have trained the model, you evaluate the model. Evaluate the model in the sense that you see whether you try to define some metrics in terms of whether there are some accuracy of the model is good or not. Uh, I mean, you get some numbers in terms of accuracy, precision, recall, this kind of numbers you will get to see whether the model is performing well or not. This is where you evaluate the model. Now, after evaluation, so in fact, before evaluation itself, there is one step which is called cross validation. So once you have trained the model, you cross validate the model using. I mean, once you have the data, you essentially split it into some parts. Some parts is used for training, and some part you keep for validation. So this is where cross validation happens to validate that whatever model you have learned is actually doing a good job. Once you have validated, then you evaluate the model. Uh, Next, you do hyperparameter optimization. You try to tweak the model, and this evaluation process is continuous. Again, you do hyperparameter optimization, and again you evaluate the model and all. So you do hyperparameter optimization, you optimize some hyperparameters of different models and see whether some hyperparameter combination works or not. And finally, once everything is done and you have found your best model with best hyperparameters, you deploy the model for prediction. Deploy for prediction. So these are all the steps in machine learning process. We are at the first step, which is data acquisition. Now we will focus on this and we'll gradually move on till the last one, which is deploy for prediction, right? So in data acquisition, we want to acquire data. So now data, when we talk about data, data are of three types, okay? Now data generally are of three types, which is like structured data. Now what structured data is? Structured data Structured data generally refers to tabular data, which is already, data which is already in form of a table. So table in the sense that you have Excel rows and columns, something you can see here, name, age, gender, and there are, so it is a very tabular data, right? So like, database table, Excel files, CSV files. So these are all examples of
Tabular data.
structured or tabular data. Now, second comes semi-structured data. What are semi-structured data? Semi-structured data are those data where, let's say you have a sensor data coming from different plants, okay? So in some cases, you may or may not have some information. Like for example, you have ID, name, and value as 3 fields, okay? So let's say your ID value is, let's say 1, your name value is XYZ, some value is there, and then this value is like, let's say 56 something. So here in the first data you have this, but in the second data you may not have. Let's say in the second data you only have ID and name, you don't have value. Or maybe you have something else. Let's say instead of value you have some test report data. So this is another column, let's say. So whose value is ABC, let's say. So here what you see is that there is no consistent schema. Here you see that each row in this has a name, age, and gender, right? Which is like tabular data and well structured. All of them have to abide by the same columns, right? Whereas in this data, some information, some data may not have those values at all. Like for example, here we don't have value field, and in the first row we don't have this test report data field, right? So these are called semi-structured data. They are structured, but all the rows don't follow the same schema or the same columns, right? So this is called semi-structured. And finally we have unstructured data. Unstructured data. Now what are unstructured data? Unstructured data are images, text files, sound, video, etc. So sound files in the sense that music files, recordings and all. So all of these are essentially unstructured data. So now what we are focusing primarily is on the structured data, where we get a data set in tabular format. We'll come to this later, during the later sessions when we talk about computer vision and NLP, because in images you do computer vision, on these text files you do natural language processing, and sound and videos, of course, like videos is like a collection of images, and sound also there are some speech to text, and then you do a speech to text, and then you work on this like an NLP problem itself, right? So these are advanced machine learning concepts which you will understand later on, but to start off with, we always start with a structured data, right? Now for this session I have pre-created some structured data already for this session number 5. So let's say we have different, as I said, data are of different formats, different types, right? So I have a Excel comma separated file, which is a CSV file. I have a JSON file. I have a Excel file, and I have a database. Okay, database itself. This is a database. Now, if you look at this, what is there in this file? So I will close this one. Okay, so what is there is we have 3 columns, name, age, and this gender, and those values are there in Excel. Same data is there in CSV as well and JSON. Now if you just look at the JSON file, this is the same data, but if you see that the name, age, and gender are repeating in all of them, and there are no new columns. So this is a structured data because the same columns are repeating. Now these are 3 formats: CSV, JSON, and Excel, and there is a database. So 4 formats, and database also has the same thing, but database stores the data in encrypted format. So if I open it in Notepad, you will not be able to see the content properly, but you will see that there are 3 columns. There is a table being created, create table, saved table, and there are 3 columns: name, age, and gender. And there is something called as Alice female, Charlie male, and Bob male. So those things are there. But I think the gender is there, name is there, the age also is like 20 something. Is that information somewhere? No, they have encrypted it, so you cannot see. So all the content you may not be able to see here, but when you read it, you will be able to read it from code. Okay, so essentially it contains the same information only. So all the 4 data contain the same information but in different format. One in CSV, one in JSON, the other in Excel, and then finally using database. Now we'll see different ways of reading the data using pandas. Okay, you are familiar with pandas. We discussed about it when discussing about key libraries about machine learning. So here we have a very simple method in pandas, read CSV to read a CSV. Now what you do is you simply do pandas pd.read CSV and it will read the CSV, and if you print it, it will get printed here. Okay. Now if you want to read an Excel, what you do is, apart from Excel name, you have to provide a sheet name. Okay, because CSV file will always have one sheet, but if you look at Excel file, it can have multiple sheets, right? So if you look at this Excel file, which is a worksheet, it has 2 sheets, sheet 2 and sheet 1. So here so essentially if you don't pass any sheet, then it will take the first sheet, which is sheet number 2 in this case, right? So I have passed a sheet number here, sheet 1, that is why it is picking the second thing. But if I just remove this one, if I remove this and execute this, it is picking up ABC, right, which is the first sheet. I'll reopen and show you. So first sheet is ABC name and second sheet is Alice, Bob, and Charlie, right? So if I don't pass any sheet name, it will take the first sheet, whatever. So you don't want to do that, because you don't know what is the first sheet, what may be the first sheet, right? So it is always a good practice to give a sheet name, what you want to extract, right? So here you pass a sheet name and you say this Excel is file, and use a read Excel to get the data. Now next comes, if you want to read all the sheets, what do you do? So you have to pass a list of sheet names here. And what this will return now is that this Excel data was a data frame, but if you do this thing, it will return a dictionary. When I do this, you will see it is returning a dictionary where the key is the sheet name. For sheet name 1, it has a data frame, and sheet name 2 again it has another data frame. So when I print the type of this, you see it is a dictionary, right? Now if I say within the dictionary I want this sheet 1, it will give me the sheet 1 data here. And if you look at what is the type of Excel data sheet 1, it is a data frame. Okay, so if you pass only one sheet name, it will give you a data frame. If you pass multiple sheet names, it will return you a dictionary whose keys are the sheet names itself, and the values are data frame for that sheet. Okay, so essentially each sheet is a data frame. Okay, so simple, read Excel and read CSV, 2 methods to read CSV and Excel. Now we come to JSON. Similarly, there is a read JSON, similar to this thing, where you pass a saved JSON and you get the same data frame, right? Simple till now. Now for SQL, so for SQL database, so for this I have used a SQL Alchemy database, that is a Python database, SQLite. So this database I have already created, and what you have to do is you have to import a create engine package from this SQL Alchemy. You have to install this package and import this create engine, and to this create engine you pass the database URL. Now so SQLite is the protocol like HTTP we use over here, right? So here if you check at any address, we have HTTP and HTTPS, right? So similarly here the protocol is SQLite, and you pass the URL of this. Now URL is the name, because we are in the same directory, we are working in the same directory. I'm just passing this saved database.db, right? So this file, if I pass, it will create a connection to that database, and then we write a query. What we say is that we say select star from saved table, right? And then we do pd.read SQL, because it's a SQL query we are firing on this table. So we do a pandas.read SQL, and we pass the SQL query, which is this one, and we pass the database connection. So this will create a connection. So we need to connect, and it will execute this query on that thing, and then it will get the data, put it in pandas data frame and show it here. Now if I run this, you will see that I am getting these 3 rows, right? But if I just change this query, if I say limit, I just want 2 rows to be returned. So you'll see only 2 rows are coming. So it is firing this query, and based on this query, it is returning the results. Okay. And this is how read SQL, similar to read JSON. This is the key API. Read SQL you have to call, and you have to pass the SQL query and the engine, and it will return the data. Now next is, if you want to get your data from some URL, let's say this is a URL where some CSV data is there. I can open this URL here and show you. So you see a lot of CSV content is there in this URL, right? You can see this, right? So this URL, there's a if you do this read CSV, because I know the type is CSV, so this read CSV method can take a path, or it can also take a URL. So if you pass a URL here, it will read from that URL and create a data frame for you. So you see the same data which is here, sepal length, sepal width and all. So here sepal length, sepal width, it extracted from this website and it created a data frame here. Okay. So essentially the purpose here, what we are trying to do is, we want to acquire data from different sources so that we can now clean, pre-process and learn machine learning models, right? So now what we saw is that we could fetch data from different formats like CSV, Excel, JSON and database. Now what we are seeing is that we can, from what sources we can, these are the formats. Now we see the different sources. So we can, maybe the APIs are same, but the format, what we are saying here is that now we are fetching the data from a URL rather than from local file system, right? So this is one way. Now second is, sometimes some API can return JSON. So this is returning a CSV, so we are calling read CSV, but some APIs can return this also. So like for example, if you look at the, hello,
Sorry.
yeah, so we have this random user API that is there, right? So if I call this API, so you'll see there is a lot of content that is available in this API, right? And here if you pass result equal to 5, so it will return only 5 entries from that JSON, from this JSON, right? So what I am doing is that I'm using a request API, I'm calling this URL, and from that response, it is a JSON, and I'm getting the results. But because if you look at that, there is a results key in this data. So I am extracting this JSON, then I am calling pandas.json normalize, and I am passing the API data. Now you will ask, why did not I use read JSON here? So the problem is, you can use read JSON, but the problem is here you are getting the JSON from a data, and from that you need to extract the results and then create your table. So it is not a very straightforward JSON where you can do. So that is why you get this result and you do a JSON normalize, and once you have done the JSON normalize, you pass it to pandas. So pandas.json normalize, you pass the API data, and it will create this API data frame for you. And this is the data frame that is getting generated. Again, these two are, this one and this one are fetching data from remote URLs, right? Not from a local file system. Now this one is where things become very interesting and little important. Now what happens, I told you Flipkart can have some data where you want to scrap and all, right? What is scrap is like, you want to crawl a website and get information from that website, right? If you look at this website, there are many things, right? So there are, if you look at, if I do a inspect element for this, no? So if I look at this source content of this, so this is essentially a HTML file. So this is a HTML file. If I hover over it, this one, anything, so you'll see the source. These are the source code, right? So if you hover over any of these things, so this is a division, this is again a division, so this is a higher division, inside a division we have another division. So this is the higher level division which is having everything. Inside that you have this division, within that division you have a span, and another span, and another division, right? So these are all HTML tags which are created, and you want to scrape the data from this website to create a tabular data for you. So how it is done is that there is a library called Beautiful Soup. you have to import this library, and then you pass the URL and you get the URL information. I mean the HTML response. Here if you do a request.get URL, you will get the response, which is nothing but this data, this HTML data. Once you have the HTML data, you pass this HTML data to this Beautiful Soup library. You pass response.content to this, and you also say what kind of parser. It is using a HTML parser, right? So you pass it, and then you apply different. You find different divisions, right? So you find all the code elements by finding all divisions which has a class code, right? So how you do that? You find all divisions which has a class code. You see here class equal to quote is written here, right? So it is trying to find all such see, all these are having class code, right? So it is finding all the divisions. Essentially it is picking out all these divisions, right? So all these 10 divisions, 10 or 9 divisions that are there here, it is getting all the divisions first in this line. So once you have all the divisions, so iterate over each division in a for loop, and for that each division you are trying to find a span with a class having a text, right? So you look at each division, you look at a span having class text, and you see some value here, right? So you expand this, so you see some data here, which is a quote, right? Quote value. So what it is doing is that this is the quote value. Now if you want to find the author, you find a tag called small and having a class author. So here if you look at a span called class called tag called small, the tag is small, right? HTML tag is small, class is author, so you get the author name from this, right? So here it gets the quote, here it gets the author name, and again it gets the tag list. So you see in that HTML is a tag list also, right? So this tag list it gets from this division, and with different class, like class as tag, it is getting all those class as tag, right? So it is saying class as tag, and it is finding all the anchor elements, so which is like A tags, right? So it is finding all the A tags and it is putting in tag list. So you found for each quote element, you got the quote, author, and the list of tags. Now you are appending quotes to quote, all the quotes to quote, authors to author, and tags to tag list, right? And then you're creating a dictionary. Now once you create this dictionary, you can directly pass a dictionary to pandas data frame as the quote data. So this is a dictionary, and you are passing this dictionary to pd.dataframe. It is creating this quotes data frame, and if you pass this, you will see that this is getting generated. So the world as we have created, so right? The first one is the world as we have created, right? And the tags are changed, deep thoughts, thinking, and world. So what it did was it scrapped data from a website and it created a data frame, right? This will be applicable in real time, wherein you have some websites from where you want to scrap data and create a data frame, and on that data frame you want to learn a machine learning model, right? So this is one thing, and the next part is the last one, wherein what we are saying is sometimes the data that we get can be from some IoT devices, like a sensor is continuously emitting data, right? So that data you want to store, and on that data you want to continuously learn. So what we do is that, let's say we have two columns, timestamp and value. What sensor is there? Is a temperature sensor in some factory, or maybe in your car, which is continuously emitting data that at this time the temperature was this, or maybe even in Apple watches and all, no? So it always emits heartbeat rate every 1 minute, 2 minutes, and all to Apple server, right? So this is like that. So you have a timestamp and you have a value. So here, let's say at 10 time intervals, or this is like at 10 time interval, we are creating new timestamp, and you have a value. We are creating generating random value, and we are creating a new row, right, with timestamp as this and value as this. And because we are trying to simulate, we don't have a real sensor from which we can get data, right? Otherwise we'll get a data directly. Here we are trying to simulate a sensor behavior. Now what it is happening is, for every time, so you can think of each for loop iteration as one sensor information coming, right? So you got some information, you created a new row with timestamp value as this and value that is coming as value, and then to this stream data frame, so I initially created an empty data frame only with column names, right? To this data frame I am adding to the you remember the lock and iLock I told you about, right? So, and this length of this thing, or here I can use iLock also, because this doesn't have the row, I mean the columns are 0 and all. I can use iLock and loop both. So stream df dot lock, I pass the length of stream database. So at the last entry, it will add a new row at the last index. So if I run this, you will understand. So at the first timestamp, you see there is one row. At second timestamp, you see there is one more row getting added. Third timestamp, third row is getting added. Fourth timestamp, another row is getting added. So at each timestamp, you say one row is getting added. So essentially, we are continuously updating our data frame based on the information that we are continuously getting from some sensor, right? So this is the last, I think. So this is another type of data collection wherein we may get data continuously from sensors, and we have to store this data and create machine learning model. So let's say we are creating a time forecasting model. Let's say even before some temperature is going to become, I mean, based on the temperature value, we can recommend whether some failure is going to happen within the next 10 minutes or 15 minutes or not, right? So what we do is we take all this data, learn a machine learning forecasting model, and based on that, decide whether some failure is going to happen in next 5-10 minutes or not, right? So this is another kind of data. So what we understood is 4 kinds of data sources: JSON, CSV, Excel, and database. And finally, different ways in which from some public URLs where data is already there, you just pass the URL, get the data and put it there. Sometimes in some URLs you may not have data directly in a format which can be consumed by pandas to create a data frame. So in that case, we have to scrape and find out relevant data and create a dictionary. And once you have a dictionary, you can create a data frame. And the last is where we have data coming in from sensors, and we have to continuously store them and update our model. Okay. So this is all for this. Go through this, and if you have any doubts, we will first discuss in the first 15-20 minutes on the doubts, and then we'll cover the next topic. And the next topic that we'll cover is data cleaning.